السلام عليكم ورحمة الله وبركاته. محاضرتنا اليوم هي representation of power system لطلاب المرحلة الرابعة هندسة الكهروميكانيكا. First of all, let's define the power system analysis. The power system analysis هي منظومة متكاملة من generation and transformation, transmission line, and then transformation and distribution. The function of power system analysis is to monitor the voltage راقب الفولتية at various passes and real and reactive power flow between two passes. Okay, and then design the circuit breakers and to plan future expansion of existing system, to analyze the system under different fault conditions, to study the ability of the system for small or large disturbance, which is the very at the beginning of the pass there's a shutdown. That means large disturbance, or small or something is cut off in the transmission line, so it's called small or large disturbance, which is stability studies. The infinite bus bar defined is a large system whose has a voltage and frequency remain constant, which is independent of power exchanges between synchronous machine and bus, and independent of excitation of the synchronous machine. So the single line diagram, as I mentioned before, which is the diagrammatic representation of power system, in which the components are represented by their symbols and interconnection between them, and they show by the straight line, even though the system is a three-phase system, and the rating and the impedance of components are also marked on the single line diagram. So a complete diagram of power system representation, all three phase, became too complicated for the system of practical size. So let's stop here. So that means in practical size يعني بالنظام بالعملي بشكل عملي كلش صعب معقد، فبالتالي احنا نحل single line diagram as I explained this in the lecture. Okay, so it's make it easy for you to solve it by convert to the single line diagram and تحله راح يكون easy لك. It's much more practical to represent a power system by means of symbols for each component, resulting in what is called one line diagram. هذني عندنا الأشكال هي شنو؟ هذني الأشكال هي represent the component of three-phase power system, which is the generator, motor, line, transformer, 2-3 winding, circuit breaker, delta Y, connection, and ground or neutral or any ground. So this figure is represents the power system diagram, which is start from generation and then bus bar and then transformer, transmission line, and then second transformer, and then the distribution system, which is the motor. And you see each component has circuit breaker to protect the system. So the impedance diagram and approximation made impedance diagram, which is the equivalent circuit of the power system in which the various components of the power system are represented by their approximation or symbol equivalence circuit, which is called the impedance diagram, is used for load flow studies. So the impedance, that means it has inductive or resistive diagram, and we can see in this diagram. So the power, the one line diagram, this we're gonna convert to the impedance diagram by changing each component. Generator, it has resistive and inductive. Okay, so with generator, so this is for generator 1, this is for generator 2, this is for the load, static load. It has just resistive and inductive, and this is the bus 1. This is the T equivalent, which is for transformer 1. It has the primary and secondary and the core. And for transmission line, this is for transmission line, which is the pi equivalent. It has two capacitance in shunt and one resistive and inductive in series. And this is for second transformer T, which has core and primary, secondary. And this is for static load, and this is for generator 3. So we convert one line diagram to the impedance diagram, as you see this. To get the reactance diagram, we're gonna see is the simplified equivalence circuit. So we're gonna simplify this equivalent from the impedance diagram to get the reactance diagram, which is simplified equivalent circuit of the power system, in which the component of forces are represented by their reactance. So the reactance can be obtained from the impedance diagram if all the resistive components are neglected. So we're gonna delete all the resistive load. So all the resistive, we're gonna neglect it, even the core on capacitance, we're gonna neglect it. So the approximation is gonna be the neutral resistance are neglect, the shunt branch and equivalence of transformer are neglect, the resistance are neglect, all the static loads are neglect, the capacitance of transmission line are neglect. So it's gonna become this circuit from the impedance diagram. You will get the reactant diagram by each component has generator and its reactance. Generator 2, it has its reactance. Transformer 1, transmission line. Transformer 2, and generator 3. So this is the reactance diagram. Okay, now is the per unit, system. The per unit system, you can define the per unit system, which is the percentage between the actual value to the base value. So this is called per unit system. So it doesn't have any units. So the per unit system, which is actual value over base value. Okay, so the equation for per unit impedance, the equation for per unit impedance, if change of base are occur. So if there is something a change in the base, so you're gonna apply this equation as I said before. So you have the impedance per unit impedance nu equal the impedance per unit all multiplied by the V load base square over V nu base and multiplied by the S base S nu and S base all. So this is the equation if the base is changed. So the per unit impedance of transformer units, so the ohmic value of impedance of transformer depend on whether they are measured on the high or low tension side. So it doesn't matter if you measure it on the high or low side. So in the per unit system, so the per unit impedance of the transformer is the same regardless of whether it is determined from ohmic values reference to the high tension or low tension side of the transformer. So you have a Z1, which is at the primary, and the percentage, the turn ratio in N1 over N2 square multiplied by the secondary of the impedance. And then you can measure parallel. You have just the N1 over N2, which is the same V1 over V2 as you see in this figure. So if you want to prove this, Z1 per unit equals Z2 per unit, you have to substitute. So Z1 per unit, you're gonna substitute V1 base square over S base, okay? And then for the secondary, you have a V2 square over S base. So by neglect the S base over S base, so you will get V1 base square over V2 base square equal N1 over N2. And then this is from Z1 per unit, you will get the N1 over N2 square to the Z2 as this formula, and for Z1 base you will get this for this formula. So by neglect the Z2 Z2 and then N2 N2, you will get the Z2 per unit. Z1 per unit equal Z2 per unit. Okay, which is just a proof. So per unit impedance of three winding transformer. So you have three winding transformer, primary, secondary, and tertiary. So this is the formula for this kind of transformer. You can see that ZPS equals Z primary and Z secondary, ZBT tertiary is Z primary and plus Z tertiary, and Z secondary tertiary is Z secondary plus Z tertiary. So to get Z primary, Z secondary, you just substitute each one of them, you will get that. So this is homework for you if you want to try to get this formula from these three equations. So the per unit impedance, which is a proof if you have like a per unit impedance of the new base megavolt ampere is twice the old base megavolt ampere, which is this megavolt ampere. S nu equals 2 as old. You can prove it by do this. So you have this formula. You're gonna substitute by this one is 2 as old. Calculate, make some mathematics. You will get this formula, and from this formula you can get the z base by multiply this is here, so equal to z per unit old multiplied by s base kilovolt old square, and then this is old, and this is the new s old and s new. The example, which is a generator rated at 30 megavolt ampere and 11 kilovolt, has a reaction of 2%, calculates per unit reactance for a base of 50 megavolt and 10 kilovolt. So the base that he already mentioned for you, he tell you the base 50 megavolt and the voltage the same. So the SC new is 50 and the kV is 10. It's already give you in the questions. And the old is 30 and the voltage is old is given for you. So the X per unit 20%, which is 20 over 100, you will get 1.2 per unit. So you can just apply the equation, which is this equation, for change base. So the X per unit new equal X per unit old multiplied by the V old over V new square multiplied by S new over S old. So the V old, which is this volt here 11, and this is 10, and this is 15, and this is 30, generally divide, and you will get 0.4033 per unit, which is easy. Example to the one line diagram. You have this one line diagram, okay, and you have this is all the component parameters. You need, what do you need? You need here to draw the reactance diagram with the all reactance mark in per unit. Select the generator rating as base in generation. هنا إذا ما أعطيك هذه عبارة إذا generator rating as a base in generator، أنت تقدر تختار إنه البيس هنا خوش وتمشي تنطلق. يعني هذا من عندك محولات، يعني معناها اكو تغير بالبيس، يعني هنا البيس يختلف، هنا اللو تنشن، هنا هاي تنشن، فيعني معناها تغير بالبيس. فمن اكو تغير بالبيس تطبق الفورمولا هاي اللي انا منطيك اياها، وبالتالي إذا ما أعطيتك إياها فأنت تفرضها وتشتغل عليها. كل الكومبوننت موجودة هنا. فيريد الرياكتنس، فأنت من تجي تحول هذا الون دايجرام إلى رياكتنس دايجرام لازم تخلي كل كومبوننت وياها البارامتر القيمة مالتها. فهنا الجنريتر لازم عندك شنو؟ لازم عندك اكس جنريتر اللي هي 0.2، اوكي، بس هذه شنو؟ هذه او، بما انه عندك انت البيس مالتك على الجنريتر اذا ما راح يتاثر، اذا تبقى 0.2، فالرياكتنس فور جنريتر ما راح تتاثر. نيجي مثلا عندك الترانسفورمر 1 انت تقدر تاخذها من البرايمري، تقدر تاخذها من الهاي تنشن، من اللو تنشن، من الهاي تنشن تقدر تاخذها. فخلينا نشوف هنا شلون بده يسوي. فانت عندك الترانسفورمر 1 اللي هي ايش قد قيمتها؟ تجيب قيمتها 0.1، فانت تقدر تاخذ الفولتيه هنا شنو؟ 20 over 230 الفولتيه بالتي 1، ف 20 over 230 تقدر تاخذ انه هنا البيس مال الفولتج ف 20 over 20 تروح، فمن تروح 20 over 20 سكوير تروح، يبقى بس الاس بيس هنا 300 للجنريتر هذا البيس، بينما للترانسفورمر اذا اشوفه 350. فش يكون 300 اللي هو الاس بيس على اس اولد اللي هو 350 مال الكومبوننت، تطلع لك الاكس ترانسفورمر 1 اللي هي هاي هنا قيمته. فور اكس ترانسميشن لاين، اذا تريد تطلع الاكس ترانسميشن لاين اعتقد هنا اللي هو شنو؟ الفي سكوير على الاس. الفي سكوير مال ترانسميشن لاين هي 230 اوكي سكوير على الاس بيس اللي هو تطلع لك الامبيدنس مال الترانسميشن لاين. عندك الاكتوال فاليو معطيك اياها بالسؤال هذا مال ترانسميشن لاين 32، تقسم قلنا نقسم شنو الاكتوال فاليو على البيس اللي انت طلعتها مال ترانسميشن لاين، على ما تطلع لك الاكس الترانسميشن لاين بير يونت للترانسميشن لاين اللي هي تمثل لي هاي. فور اكس ترانسفورمر 2 إذا شوف هنا بالسؤال X2 is composed of three single phase transformer each rated 100 and 127 over 13.2 كيلو فولت. So راح تضرب هاي بثلاثة ليش 3 single phase transformer راح يصير 300 راح تضرب هاي في روت 3 على مود شنو على مود تصير 4 3 phase فراح يطلع لك التيار ريشيو مال 2 transformer second 220 over 13.2 while the S للترانسفورمر 2 اللي هو 3 باي 100 300 ميجا فولت. من تريد تحسبها انه ايش عندك القيمه مالتها مال الترانسفورمر 2 عندك 0.1 multiply by the S base عندك 300 هو 300 ما راح تتاثر بينما الفولتيه اللي هي 20 للبيس والفولتيه اللي هنا الفولتيه 20 للبيس فور جنريتر 20 اوكي بينما للترانسفورمر سكند اللي هو اذا تاخذها لللو تنشن هو هنا نقدر ناخذها لللو تنشن فاخذ 13.2 اذا اخذت 13.2 هنا يعني الفولتيه هنا تحسبها فلازم شنو؟ لازم تاخذ الفولتيه اللي هي مو ال 20 كيلو فولت وانما تاخذ الفولتيه اللي 13.8 للماطور اللي هو هذا مال الماطور اوكي ليش؟ لان 13.2 multiply by 230 مال ترانسميشن لاين اوفر 230 مال الترانسفورمر بالهاي تنشن تطلع لك 13.8 هاي الفولتيه البيس بالماطور فتاخذ هاي الفولتيه بينما اذا تريد تاخذ الهاي تنشن لازم تعتبر انه ال 230 هي عندك مال الترانسميشن لاين وال 220 مال الترانسفورمر فيصير عندك هنا الفولتيه اللي هي حسب المعادله الفولتيه بالاولد اللي هي 230 اوفر 220 جربها وشوف راح تطلع لك نفس القيمه نظام مال 0.1 تطلع لك نفس القيمه مال هذه يعني اذا اخذت 13.2 اوفر 13.8 او اذا اخذت الفولتيه بالهاي تنشن هذا باللو تنشن لان البيس هنا باللو تنشن 13.8 والفولتيه مال الترانسفورمر 13.2 الاولد هنا على شنو؟ على النيو حسبناها باللو تنشن 13.8 بينما اذا تريد تاخذ بالهاي تنشن انت هنا موجود بالهاي تنشن شو تقول الاولد اللي هي شنو هي الفولتيه مال الترانسميشن لاين الاولد اللي هي 220 اللي هي قد 220 هاي 220 هاي الاولد اوكي على النيو هي مال ترانسميشن 230 فتقسم 220 على 230 سكوير multiply by 0.1 تطلع لك 0.019 فور الموتور عندك فور موتور هذين الموتور 1 و 2 اثنيناتهم نفس الرياكتنس 2.2 الاس 200 و100 هنا 300 والفولتيه 13.2 اعتقد الفولتيه ما راح تتاثر بس فقط الاس 3 على 2 3 على 100 13.2 على 13.8 هذا البيس بالهذا 13.2 على 13.8 اللي البيس مال هذا فتطلع لك الموتور تجي تعوض كل القيم بالرياكتنس دايجرام هو المطلوب ماشي فشكرا جزيلا هنا محاضرتنا تنتهي شكرا جزيلا